Hi everyone, welcome back to my channel. Today we are discussing some numericals related with electricity and electromagnetism. These numericals will help you a lot in the coming exams. So listen carefully. So in electricity, many of the numericals in electricity, it has the same format. Just I am drawing a circuit. This is a battery. It is connected to two resistors. Then again connected with another resistor. This is a circuit. Suppose I am applying 12 volt. Battery is connected. Suppose this is 2 ohm, this is 3 ohm, this is 6 ohm. 2 ohm, 3 ohm, 6 ohm. So this is a simple circuit. So in many of the numericals from electricity, they are asking first find the total resistance. Total resistance or equivalent resistance or effective resistance in the circuit. Total resistance or equivalent resistance or effective resistance in the circuit. Then they can ask for the total current. Total current in the circuit. It can ask for total current in the circuit. Then they can ask for the voltage across the parallel combination. Voltage across the parallel resistors. Then they can ask for the current flowing through the parallel resistors. Current flowing through 2 ohm or current flowing through 3 ohm. So these type of questions are common in different questions from electricity. So here a source is there which is providing 12 volt. Here there are two resistors connected in parallel and 6 ohm is connected separately. So normally from electricity unit, they are asking for finding the total resistance and then calculating the total current, then voltage across the parallel combination of resistors or voltage across here 6 ohm, voltage across 2 ohm or voltage across 3 ohm. Then they can ask for the current flowing through 2 ohm and 3 ohm. These type of questions are there in electricity numericals. So for the explanation, I took an example. So here we can do the numericals. First we can calculate the total resistance. How will you get the total resistance here? Here two resistors connected in parallel. Which is the equation for doing that one? 1 by R equal to 1 by R1 plus 1 by R2. So 1 by R equal to, here the two resistors are 2 ohm and 3 ohm. So 1 by 2 plus 1 by 3. Then 1 by R equal to 2. 2 and 3. LCM is 6. So 6. 3 plus 2. 3 plus 2. It is 5 by 6. Most of the learners, they will make mistakes. They will make mistakes when they calculate R. They will not take the reciprocal. So here the reciprocal is R equal to 6 by 5. 6 by 5 is 6 divided by 5. It is 1.2. 1.2 ohm. So if the two resistors are connected in parallel and the values are 2 ohm and 3 ohm. This is the way how to get the equivalent resistance. This is the way how to get the equivalent resistance. R equal to 6 by 5, 1 by 2, it is 1.2 ohm. Okay. If there are 3 resistors, for example, if there are 3 resistors, one, 2, 3. For example, 2 ohm, 4 ohm, 6 ohm. 2 ohm, 4 ohm, 6 ohm connected in parallel. There are 3 resistors connected in parallel. How to get the equivalent resistance of that? So the equation remains same, 1 by R equal to 1 by R1 plus 1 by R2 plus 1 by R3. Then 1 by R equal to 1 by R equal to 1 by 2 plus 1 by 4 plus 1 by 6. Then find the LCM of that. 2, 4, 6. 2, 1, 2, 3. It is 12. So 1 by R equal to LCM is 12. 6 plus 3 plus 2. That is 1 by R equal to 9, 11 by 12. So don't forget to take the reciprocal. So here R will be R equal to 12 by 11. 12 by 11 we can calculate by using the calculator. 12 by divided by 11. It is 1.09. 1.09. So here the three resistors you can replace by 1.09. 1.09 ohm. So the 3 resistors are replaced by 1.09 ohm. So this is the way how to get the equivalent resistance if there are 3 resistors connected in parallel. If there are 2, 1 by R equal to 1 by R1 plus 1 by R2. If there are 3, 1 by R equal to 1 by R1 plus 1 by R2 plus 1 by R3. So now these two they are in series. So 1.09 ohm plus 6 ohm, they are in series. So the effective resistance or total resistance equal to 1.09 plus 6. 1.09 plus 6. 1.09 plus 6. It is 7.09 ohm. 7.09 ohm. So this is the total resistance in the circuit, or this is the effective resistance in the circuit, or this is the equivalent resistance in the circuit. So this is the way how to get the equivalent resistance in the circuit. If there are a number of resistors in the circuit, there were 4 resistors, but now only 1 resistance. So the 4 resistance are replaced by a single resistance, that is 7.09. That is the equivalent resistance of the 4 resistors. So we are calculated by the first thing, we are calculated by 1 by R equal to 1 by R1 plus 1 by R2 plus 1 by R3. Then you are getting the total resistance in parallel combination, that is 1.09 ohm. That resistance comes in series with the 6 ohm. Then the total resistance become 1.09 plus 6. It is 7.09 ohm. So that is the total resistance in the circuit. Then we can calculate the current in the circuit, total current in the circuit. How will you get the total current? How will you get the total current? Total current, how will you get it? We have the equation V equal to IR. So I equal to V divided by R. V is 12 divided by 7.09. 7.09 0.09. So you can calculate that it is 12 divided by 7.09. It is 1.69. 1.69 ampere. This is the total current in the circuit. So how will you get the total current? Total current equal to total voltage in the circuit divided by total resistance in the circuit. So total voltage is 12 and the total resistance is 7.09. So this is the total current in the circuit. So when you calculate a quantity, you must write down the equation for that. You will get 1 mark for that. So don't forget to write the equation for that quantity. So in the first case, we calculated the total resistance, and in the second problem, we are calculating the total current in the circuit. So this is the way how to get the equivalent resistance or effective resistance or total resistance in the circuit. Then by using that, you can calculate the current in the circuit, total current in the circuit. So these two types of questions you can see in different question papers. In electricity problem, there will be calculation of total resistance in the circuit, effective resistance or equivalent resistance, and after that you have to calculate the total current in the circuit. So total current equal to total voltage divided by total resistance. So here R is the effective resistance, that is equal to 7.09. There were 4 resistors. We are replaced these 4 resistors by a single resistance, that is 7.09. That is known as effective resistance or equivalent resistance or total resistance in the circuit. And we are calculating the total current. So this is the way how to get the total resistance and the total current. Then we can solve the other problems. How will it ask? So for that I am drawing another circuit. For example, this is 6 volt. This is 2 ohm, 4 ohm and 6 ohm. And another value 2 ohm. So here another circuit. First I am calculate the equivalent resistance. 1 by R equal to 1 by R1 plus 1 by R2 plus 1 by R3. That is 1 by 2 plus 1 by 4 plus 1 by 6. 1 by 2 plus 1 by 4 plus 1 by 6. 2, 4, 6. 2, 1, 2, 3. 12. 6 plus 3 plus 2. It is R equal to 12 by 11. You will get the same answer as you obtained from the last question. 12 by 11. 12 by 11 was 1.09 ohm. Then the total resistance become 2 plus 1.09. That is equal to 3.09 ohm. 3.09 ohm. Then, so total resistance in the circuit is 3.09. R equal to 3.09 ohm. Current equal to 6 divided by, current equal to voltage divided by resistance. So, 6 divided by 3.09. 6 divided by 3.09. It will be 1.94. 1.94 ampere. So you are getting current. So I am just marking this as current. I equal to 1.94 ampere. So this is the total current and the total resistance in the circuit. So here the current will be 1.94 ampere. It is flowing through the resistors. So when the current reaches here, it will split into 3. 1, 2, 3. And when it reaches here, the current will be 1.94 again. So 1.94 current is splitting into 3 and again it combines into 1.94 and that current flows through 2 ohm. So the question can ask, what is the voltage across this parallel combination? What is the voltage across the parallel combination? So how will you get it? We are using very simple equations, but some logics we are applying. So here you can calculate the voltage. What is the reason? Because the current flowing through 2 ohm, you know it, and the resistance is 2 ohm. So here the voltage will be I into R equal to 1.94 multiplied by 2. 1.94 multiplied by 2. So 1.94 multiplied by 2. It will be 3.88 volt. So 3.88 volt comes here. 3.88 volt comes here across 2 ohm. So across 2 ohm there will be 3.88 voltage. Across 2 ohm there will be 3.88 voltage comes here. Okay. So how you are getting it? You just multiply the current flowing through 2 ohm and 2 ohm resistance. You will get 3.88 voltage. So voltage across a device equal to what? Current flowing through the device multiplied by its resistance. So current flowing through the resistance is 1.94 multiplied by 2. You will get 3.88 voltage. So here will be 3.88 voltage comes here. So 3.88 voltage comes from the total voltage 6 volt. 3.88 voltage from where it is getting? From the total voltage 6. Okay. So the remaining voltage comes here. So the remaining voltage is what? 6 minus 3.88. 6 minus 3.88. It will be 2.12 voltage. So 2.12 voltage comes here. And this 2.12 voltage will be same to 2 ohm, 4 ohm and 6 ohm because these three are connected in parallel. You know that when the resistors are connected in parallel, they will get the same voltage. So the remaining voltage is how much? 2.12. And that voltage will be common to these three resistors. So this parallel combination of resistors gets how much voltage? 2.12 voltage. So 2 ohm will get 2.12 voltage, 4 ohm will get 2.12 voltage, 6 ohm will get 2.12 voltage. So this is the way how to get the voltage across each resistors. If the resistors are in parallel, they will get the same voltage. So now another question it can ask. What type of question it is? The current flowing through 2 ohm. How will you get the current flowing through 2 ohm? You know that current equal to voltage divided by resistance. Current flowing through 2 ohm. How will you get it? Voltage across 2 ohm. How much it is? 2.12. 2.12 divided by its resistance, that is 2. You will get the current flowing through it. What is the current flowing through 4 ohm? Voltage divided by its resistance. You will get the current. What is the current flowing through 6 ohm? Voltage divided by its resistance. You will get the current. When you add these three currents, the sum will be 1.94. Because when 1.94 comes here, it is splitting into 3. So that's splitted currents are these three. So when you take the sum of these three, you will get 1.94. So how will you get the current flowing through each resistors? Divide the voltage across the resistor and divide by its resistance. So what is the current flowing through 2 ohm? Its voltage divided by its resistance. What is the current flowing through 4 ohm? Its voltage divided by its resistance. What is the current flowing through 6 ohm? Its voltage divided by its resistance. So you will get the current flowing through each resistors which are connected in parallel. So that is one of the questions in the electricity. Then you can say which is having more current. So that thing you can easily calculate. If the resistance is high, current will be less. So that means what? Along 6 ohm the current will be less. Along 2 ohm, through 2 ohm current will be more. So the current is more through 2 ohm and less to 6 ohm, less through 6 ohm. So that type of questions can ask. In parallel combination, through which resistor the current is more and current is less. Okay, voltage is same everywhere. So if the resistance is more, current will be less. If the resistance is less, current will be more. Current will be more. Then what is the current flowing through this 2 ohm? It will be 1.94. 1.94 current flowing through it. So these type of questions are generally in the electricity numericals. So which are the different types of questions can ask in the electricity numericals? First, total resistance in the circuit. That is effective resistance or equivalent resistance. Total resistance in the circuit. There can be parallel combination and a separate resistor is there. If there are two resistors in parallel, 1 by R equal to 1 by R1 plus 1 by R2. If there are three resistors in parallel, 1 by R equal to 1 by R1 plus 1 by R2 plus 1 by R3. When you do this, don't forget to take the reciprocal at the end. And the effective resistance, you will get it and you express the value in ohm. So that effective value of the parallel combination comes in series with the another resistance. Take the sum, then you will get the equivalent resistance or effective resistance or total resistance in the circuit. So that is one of the question. Then the question can ask, what is the total current in this circuit? How will you find it? In the question, if it is giving the total voltage. So current equal to voltage divided by resistance. Total voltage divided by total resistance. You already calculated total resistance. Voltage is given in the question paper. So take the ratio, you will get the current that you express in ampere. Then they can ask, which are the current flowing through the parallel combination of resistors. So all parallel resistors will get the same voltage. How will you get that voltage? First to find out this voltage. Its voltage will be current flowing through 2 ohm. So 1.94 multiplied by 2. Because the current voltage across a resistor is equal to current flowing through the resistor multiplied by its resistance. So here it will be 1.94 multiplied by 2. So you will get 3.88. That 3.88 from where you are getting? From 6. So the remaining voltage, that is 2.12 voltage, comes across these three parallel combination. That means 2 ohm, 4 ohm, 6 ohm, they all will get 2.12 voltage. Then how can you calculate the current flowing through each parallel combination of resistors? 2.12 divided by 2, 2.12 divided by 4, 2.12 divided by 6. Then you will get the current flowing through each resistors. Then you can find out through which resistor the current is maximum and current is minimum. So if the resistance is more, current will be minimum here. If the resistance is less, current will be maximum here. So these are the type of questions from electricity problem. Then you learned about electric power. For calculating electric power, there are three equations. P equal to IV P equal to I square R, P equal to V square by R. In the question, if the current and voltage are given, you can calculate the electric power by just multiplying it. In the question, if they are giving current and resistance, you calculate the power by multiplying I square and R. In the question, if they are giving voltage and resistance, you use this equation. So electric power you can directly calculate by using any of these equations. And after calculating electric power, suppose the question is asking what is the resistance of the device. The device can be a kettle, a geyser, an electric bulb. How will you get the resistance? So resistance you can calculate by using any of these two. That means power divided by I square or V square divided by P. If the voltage is given, P divided by resistance equal to V square divided by P. Here will be equal to power divided by I square. So from this equation, resistance equal to P divided by I square. From this equation, resistance equal to V square divided by P. So if the power you can calculate, and I is given in the question, maybe. And here the voltage is given in the question, power you already calculated. So you can use any of these two equations for calculating the power of the device. So that way you can calculate the resistance of the device and the power of the device. So power you can calculate by using any of these three equations. Then the question can ask what about the resistance of the device used in the used. So resistance equal to power divided by I square, resistance equal to V square divided by P. Any of these you can use it. So these are the type of questions can ask. Another thing from electromagnetism, finding the induced EMF. What is the equation for that? Epsilon equal to minus n delta phi divided by delta t. N normally will be 1. There is no need of putting minus, so delta phi divided by delta t. Delta phi divided by delta t. That means induced EMF equal to rate of change of flux. Rate of change of flux. So if there is a change of flux, you can delta phi equal to what? Phi 2 minus phi 1. If the change in the flux is directly given, or the initial flux and final flux are given, you can substitute directly there. And the time will be given in the question. So you can calculate the induced EMF. So if the induced EMF, if it is given for calculation, flux equal to BA cos theta. The change in flux can takes place because of the change in the angle or because of the change in magnetic field. If B is changing or theta is changing, that will make a change in delta phi. So delta phi you can get, delta phi is produced because of the change in B or because of the change in the angle. So if in the question if they are given the change in the magnetic field or change in the angle, so always remember the angle is the angle between the magnetic field and the normal of the coil. Suppose if it is the coil, this is the coil plane, or this is the surface of the coil, or this is the plane of the coil. The normal of the coil will be like this. Okay, so the angle will be always between normal of the coil and the magnetic field. In some questions they are giving directly. Otherwise you just take the difference 90 minus given angle. So in some questions they are giving directly and some other questions they are not given directly. So if this is the surface of the coil or this is the plane of the coil, the normal of the coil is like this. If the magnetic field is coming like this, so between them there is an angle. Between them there is an angle. So that angle you are considering here, theta. Don't take the angle between the field and the surface. Don't take the angle between the field and the surface. It is the angle between normal of the surface and the field. Most of the questions they will give the angle between normal of the coil and the field. Then you can directly substitute. Otherwise, you take angle how? Take the difference between the angle and 90 degree. If it is given 30 degree, you take 90 minus 30, it will be 60 degree. Otherwise, you take directly as 30. So, always check the question. The angle is given between the normal of the coil and the field. If it is given like that, you can take directly. Otherwise, take the difference between 90 and the given angle. So, most of the question they are giving directly. So, you can take the angle directly. So, always take angle between normal of the surface or normal of the coil and the field. Okay, you check the question, it is clearly written in the question. If they are saying normal of the coil and the field, you can take the direct angle. So, the flux can be changed by the change in the magnetic field also, B. So, if there are two fields, if the magnetic field is changing, you can take B2 and B1. There will be B2 and B1. So, B2 minus B1. Then A cos theta. Here area will be a constant and theta also will be a constant. Theta is constant, magnetic field is changing. Magnetic field is expressed in Tesla. So, for example, 2 Tesla to 3 Tesla. So, there will be a change in the magnetic field. So, B2 minus B1 produces delta phi. So, change in the magnetic field produces change in the flux. So, B2 minus B1, then A, then cos theta. So, in this case, area of the coil and the angle of the angle will be a constant. What produces magnetic flux change? The field change. Because of the change in the magnetic field, the magnetic flux is changing. So, you can find out delta phi. Then, delta phi you substitute here. Delta T will be there in the question. Then divide these two, you will get induced EMF. So, induced EMF you can directly calculate like this way. B2 minus B1 A cos theta. Then, after calculating induced EMF, normally the question is followed by induced current. So, induced current equal to induced EMF divided by resistance. That means you already learned the equation I equal to V by R. Instead of V, here it will be induced EMF. And the resistance will be in the question maybe. If it is given in the question, just divide, you will get the induced current.